Hello and welcome you all. In the last video, we have studied composition of function, that is fork function and golf function. Now we will do some important questions which have asked previously in board examination. So our first question for today is, let function f from 2, 3, 4, 5 to 3, 4, 5, 9 and a function g from 3, 4, 5, 9 to 7, 11, 15 be a function defined as f2, 3, f3, 4, f4, f5 equal to 5, g3, g4 equal to 7 and g5, g9 equal to 11. So when we have to find golf function. So as you know, g of fx can be written as g o means bracket fx. As per question, domain of f is 2, 3, 4, 5. So on substituting first element of domain, that is 2, we get g f2 and at f2 we have 3, so g3 equal to 7. Similarly student, one more time, second element of domain of f is 3. So g f3 as f3 as per our question is 4. So g of 4 equal to 7. And similarly, we can solve it for other elements of domain of f. So finally we get g of f equal to 3, 7, 4, 11, 5, 11. This is our final answer. Our next question is, let function f from R to R be a signum function. As we know in class 11 that range of signum function is 1, 0 and -1. 1 for x is greater than 0, 0 at x equal to 0 and -1 at x less than 0. And other function g from R to R be a greatest integer function or floor function such that gx equal to greatest integer function x. In this question, we have to prove that fog and golf function coincide. F of gx equal to f o means bracket gx equal to f, and in our question student gx equal to greatest integer function. So f in bracket we have greatest integer function. So at x equal to -1, the greatest integer function will always give -1. Now we have to find the value of f of -1. We know that signum function at x less than 0 is always gives -1. So f of g equal to -1. Now g of fx equal to g o means bracket fx. As per question, we have to check for x equal to -1. So g of -1 and this -1 is value of x, and we have to substitute this value in g function in place of x. So as we know that gx is greatest integer function, so -1 will always give us -1. We have concluded that f of gx and g of fx both have same value, that is -1, means they both will coincide. Now student, based on above question, practice this question and find g of f. Now student, our second topic is to find inverse of a function. So first we will learn and understand the practical approach, and after that we will do the theoretical approach, which is very, very important. So students, if a function is one when onto both, the function is bijective. And if it is bijective, then function is also invertible. Let's say I have taken a function f from a to b, where elements of a are 1, 2, 3, and elements of b are a, b, c. So here student, 1 is related to a, 2 is related to b, and 3 is related to c. Means our function is 1, 1 and onto both. So student, we know that f of 1 equal to a, f of 2 equal to b, and f of 3 equal to c. So from here, what is f inverse a, which is equal to 1, and f inverse b equal to 2, and f inverse c equal to 3. So in this Venn diagram, only one inverse exists, means function is bijective. So if it is bijective, then its inverse exists. Now in our second Venn diagram, in set A, we have 1, 2, 3, and set B, we have only 10. So 1 is related to 10, 2 is related to 10, 3 is related to 10, means all the element of domain are related to single element in codomain, that is 10. So from here, f1 equal to 10, f2 equal to 10, and f3 equal to 10. If f1 equal to 10, then f inverse 10 equal to 1. Similarly, f inverse 10 equal to 2, f inverse 10 equal to 3. Means here 2 or more inverse exist. So function is not bijective. That means here inverse does not exist. So this is our practical approach, student. Now student, next we will do the theoretical approach of invertible function. So as per the definition of invertible function, a function f from x to y, here x is domain and y is codomain, is defined to be invertible if there exists a function g, means there exists some other function g from y to x, here y is domain and x is codomain, such that g of f equal to ix and f of g equal to iy. Then the function g is called inverse of f and denoted by f inverse. By this definition of NCERT, you are not able to clearly understand the invertible function. So we will do an example, and simultaneously I will tell you the algorithm to find the inverse of a function. Student, our question is, if a function from R to R is defined by fx equal to 2x plus 7. So we have to prove that function is invertible, and if it is invertible, then we have to find the inverse of f also. So as per algorithm, our first step is put y is equal to fx. This is our step 1. So we get y is equal to 2x plus 7. Now we have to find x in terms of y. X की वैल्यू निकालनी है y के टर्म्स में. So we get x equal to y minus 7 upon 2. Now student, this y minus 7 upon 2 belongs to real number. Then if y minus 7 upon 2 belongs to real number, then x should also belongs to real number. So student, to find inverse of our function, here exists some other function g from R to R. Now according to our algorithm, step 2 is we have to prove f of gy equal to iy, or you can say y also, and g of fx equal to x or ix. So student, this is our second step. Now first we will prove f of gy equal to f o means bracket g of y. So according to our question, g of y equal to y minus 7 upon 2. So f bracket y minus 7 upon 2 equal to, and you all know that in this f function is the value of x, and we have to put this value in f function in place of x. So finally we get 2 in place of x, y minus 7 upon 2 plus 7. So on solving it, we get equal to y, or we can also say it is equal to iy. Similarly, student, now we will find g of fx. So g bracket fx equal to g fx is 2x plus 7. So g of 2x plus 7 equal to, so this is the value of x, and now we have to put this value of x in g function in place of x. So 2x plus 7 minus 7 upon 2. On solving it, we get that this is equal to x, or we can say equal to ix. Now student, since f of gy equal to iy and g of fx equal to ix, we have already proved this. Now we can write that gx function equal to x minus 3 upon 4. Means now we have proved that this function is bijective. The function g is called inverse of f, such that f inverse x equal to x minus 3 upon 4. So by this way, we can find the inverse of a function. So by this video, we learn that if function is bijective, means 1 1 and 1 2 both, then our function is invertible, or its inverse exists.